So in the previous video, we learned about nodes and master nodes. Now I've been trying to find good diagrams or images for the proof of work, because I thought it'll be easy to explain to you with just one diagram. But the problem is I couldn't find the right diagram. I mean, I looked through everything on the internet. I couldn't find the right one, right? So also I'll leave in a link to this article, Blockchain Council, where the last time we talked about nodes and master nodes. So in case you want to read more, you can read more from here itself. Okay, yeah. So I couldn't find it, so I had to build it myself. I built the whole diagram myself. So I'll show it to you actually how proof of work actually works. But first, let me take you through what I found on the internet. Okay, so according to the internet, this is how proof of work works, where you have miners, right? Miners basically are people who are going to have a node, or people who are going to be operating a node. You can be one, so you can probably take up an AWS server and download the entire node software on it for the particular blockchain, and then become a miner if you want. And miners are people who get to add a block to the blockchain, and then they get paid. So they have to solve a block puzzle. Then they basically broadcast the new block to the entire network. It gets verified by different miners, and the process starts again. So there will be multiple transactions that keep happening on the blockchain, like somebody transferred money to this guy, somebody transferred money to that guy, all those transactions. And many transactions then are taken into one block, and then the whole process keeps repeating, right? So this is one image that I found. It doesn't cover the entire picture, but I just want to show it to you. And then here you have the same thing, where a new block is created, and all of the miners in the network, all the nodes, try to solve the puzzle, the cryptography puzzle. Once the one guy solves it and he wins, he will then broadcast the entire new blockchain to the entire blockchain, basically to the entire network, basically. And then the new block gets added to the network, and then the repeat process happens. Okay, so this is just the simple diagrams that I found on the internet, but there are layers to it, so that's why I wanted to show you what actually happens. All right, so here are these three guys, okay, who want to make some money on online. So what they've done is they've started operating their own nodes. So somebody bought an AWS server, somebody bought DigitalOcean, somebody bought, let's say, Google Cloud Server. They have started running nodes for the blockchain that they care about. Maybe it could be Ethereum, could be Solana, whatever. So they're operating these nodes. It could be you, right? It's very now these days it's very simple to simply start a node on any of the servers. So let's say these guys are running these nodes. Now this is the blockchain, complete blockchain, and then a new block has to get added to the blockchain, right? So each block has a lot of transaction related data. So what exactly is transaction, right? Transaction is not just like money, somebody purchasing something and money getting transferred. It's not just that. It's a lot more than that. So anything that changes the state of the blockchain is called a transaction. So somebody bought NFTs, somebody transferred NFTs to somebody else, somebody got some cryptocurrency, somebody transferred cryptocurrency to somebody else, and so many other things, right? All of those can be called as a transaction. So a block has a lot of data of lot of transactions, so about 30, 40, 50, depending on the block size. You'll have all of those transactions. Now all of those transactions will be added in a block, and that block needs to get added to the blockchain, right, to keep increasing the size of the blockchain and to keep increasing the transactions that the blockchain stores. That's how a blockchain evolves. It just keeps becoming bigger and bigger. Now all of these nodes, as you know, they store the entire copy of the entire blockchain. They store the complete copy. So that's why you need very good processing power, very good storage power, because the size of the blockchain will keep increasing, and you'll have to have really big servers that are connected with a very good internet connection to the rest of the peers or the other nodes on the network. So this is why when the transactions slow down, this is why they're slowing down. You must have heard, right, that Ethereum can only scale this much. It doesn't have a lot of processing power, or whatever you hear, basically the transactions going slow. Whenever you hear that, whenever you read that in the news, this is what it means, that the transactions can't scale up beyond a particular speed, is because the transactions, once they happen, they have to be copied by all of the blocks, all of the nodes in the entire blockchain. Okay, so they have to be copied by all of the nodes. So this is the reason why it's very difficult to scale blockchains very easily. But there are ways. So we'll talk about L2 and ZK rollups and all those ways to scale up blockchains. This video is not about that. We'll talk about that as your knowledge about blockchains increases. So the node that gets to add the next block, right? So getting to add the next block is a big thing. If you get to add to the next block, you get paid. So that's called as mining, right? You get paid. So what in proof of work, what happens is all of these nodes, right? There are 3, but there could be hundreds. All of them, because they want to add the next block to the blockchain, all of them, they solve some crypto hash puzzle or problem. And I've showed that to you in the previous video where we saw the entire blockchain visualized, that demo. We saw how the nonce starts from a particular number, and then it has to go all the way, and then it has to match the hash, and then that basically solves the problem, and that's called as mining the node. So whichever one of these does that the fastest, that's why you need more and more processing power, because whichever one of these does it fastest will get to win. So there's one clear winner here. Now there is a complete topic about ASIC mining and all of that, so I'll talk about that also, because now the mining game has become very, very advanced. But I'm just talking from a very general perspective that let's say you just have a server as a node, as a mining node. Okay, so whoever gets to whoever solves the puzzle fastest, it becomes the clear winner, and then he gets to add the block to the blockchain. Okay. And here I've written that each node has a complete copy of the blockchain. That's quite clear. So now the clear winner gets to add the new block to the blockchain, and then he then broadcasts that to the entire network. So now that new blockchain gets broadcasted to the entire network, and the rest of the nodes will some of the nodes will verify and validate it, and the rest of the nodes then will copy this new blockchain. So this is the entire process. This is the entire diagram, right? So I want to take you through that. Sadly, on the internet, I couldn't find anything that resembles this, because you have to show, right, all these nodes competing to solve the problem, and then one clear winner who gets to add. So all of this wasn't there somehow on the internet. So that is it. So that's it for today's video, guys. In the next video, we will talk about proof of stake. Now, one really important thing is that in my videos, if you go to the Golang 42 projects, I think it's 42 projects playlist series. Now it's 42. Earlier it was just 17, 20. Slowly I kept adding to it, and now it's 42 projects playlist series. If you go there, I have a project on building a blockchain from scratch. And then I have a new project which is that's using proof of work. So you'll build a new blockchain from scratch which uses proof of work. And soon I'll be coming up with another blockchain which will have proof of stake. Then I'll have another blockchain that will be a peer-to-peer. We'll have multiple nodes and peer-to-peer. And then we'll have, after a while, we'll have a completely fully ready blockchain which will have wallets and transactions. It will support all of that. So I'm just building your knowledge, but all of this is not in isolation. You actually get to build and code the project with me after you learn this, right? So is this not just some jargon and theory? I don't believe in all that. I have to teach you all of this so that you can code much better with me. Okay, so go to my Golang projects. There's a blockchain from scratch with Golang. You build the actual code. Then there's a blockchain, proof of work blockchain. And then in the next video, we'll get in this series of this, the next video of this series, we'll get to learn about proof of stake. And then you'll also get to build a proof of stake blockchain with me in Golang. Okay, so there's a lot of stuff happening. Make sure you subscribe to this channel, because you get all of this awesome information. Thank you for watching, and I'll see you in the next video.